Now let's talk about how to we find integrals involving powers of sine and cosine functions. Because so far, what we've had integration formulas per specific function. We've also learned how to integrate using the substitution method, and also we've learned how to integrate by parts. So now in this section, we're going to look at quite a few integrals involving trig functions and some of the techniques we can use to evaluate them. So let's try evaluating these integrals. So for the first one, we have here the integral of cosine x sine to the fifth x dx. Sine x to the fifth dx, sorry. So if we're going to let u be equal to sine x, why the dx? Sine x du will be equal to cosine x dx. So therefore, this gets replaced by u, and we can do the u substitution. This becomes u raised to 5 du. With that in mind, following our basic integration formula, this becomes u to the 6 over 6 plus c, which becomes sine x to the 6 over 6 plus c, or 1/6 sine x to the 6. Because of the presence of cosine x, substitution rule is easy to do. However, in the second one, there's no presence of cosine x dx. So it's kind of difficult to do our u substitution. So how are we able to do this one? We cannot do also integration by parts because it will not work that well. So instead, we can use this. If our sine or cosines are in odd powers, we can somehow do factoring so that we can do our Pythagorean identity. We can apply the Pythagorean identity cosine squared x plus sine squared x equals 1. If the powers of our sine and cosine are even, we can use the power reducing identities so that it will help us in integrating our integral. So let's work with sine to the fifth x. So for the integral of sine to the fifth x dx, there you go. We have 5 as the power, and that's odd. So we have to use our Pythagorean identity. So to do that, let's go back again. To use the Pythagorean identity, we need to flesh out an even power, then multiply it to an odd power. So the largest even power that you can flesh out, that's what you flesh out. For example, here, I can write this actually as the integral of sine to the fourth x times sine x dx. So there you go. So from here, sine to the fourth x can be rewritten as sine squared x squared, then sine x dx. So with this, sine squared x, based on our Pythagorean identity, cosine squared x plus sine squared x plus 1, sine squared x equals 1, sorry. Sine squared x equals 1. So sine squared x will be equal to 1 minus cosine squared x. And that's one possible thing that we can use because we can use the u sub, just like what we do here. So therefore here, this becomes the integral of 1 minus cosine squared x squared sine x dx. Now, with this, if we can now use u sub because now cosine and sine are present to each other. They are present with each other. So if we're going to let u be equal to cosine x at this point, du will be equal to negative sine x dx. So therefore, I'm going to have here integral of 1 minus u squared negative du. So that gives me negative integral of 1 minus u squared du. So for us to be able to integrate this better, we can expand this. So I'm going to now have, let's not forget that's the negative integral of 1 minus 2u plus 2 squared du. So this becomes now the negative in. So what I'm going to do so that it's easier, let's already distribute this negative. So we'll have the negative integral of du. That's plus, because it's negative plus negative, that's plus 2 the integral of 2 du minus the integral of u squared du. So therefore, we're going to have negative u plus, this becomes 2 times u squared over 2 minus this is u cubed over p plus c. Sorry, this is my bad. My expanding this one. This should have been, let me do this. This should have been 1 minus 2u squared plus e to the 4th du. My bad. So this becomes negative integral of du plus 2 integral of u squared du minus integral of u to the 4th du. There you go. So this becomes negative u plus 2u cubed over 3 minus u to the 5th over 5 plus c. So since u is equal to cosine x, therefore the integral of sine to the 5th x dx is equal to negative cosine x plus 2/3 cosine cube x minus 1/5 cosine to the 5th x plus c. So that should be 5x plus c. So again, the main idea is if the power raised is odd, we might have to extract the highest even one so that we can perform we can use some identities so that to show that we can then do u sub later on. So let's have this example. So here we have, this time it's cosine that's raised to the 5th power. So following what we had a while ago, we'll have cosine to the 5th x dx is equal to the integral of cosine to the 4th x dx times cosine x dx. So just like what we did a while ago, this time we're going to turn this to 1 minus sine, just to show first to the others, this is cosine squared x squared, and that's cosine x dx. So this becomes du, we need a sine. For this to become du, we would need a sine. Hence, this becomes the integral of 1 minus sine squared x squared cosine x dx. So from here, if we're going to let u be equal to sine x, du will be equal to cosine x dx. Hence, this becomes the integral of 1 minus u squared du. And just like what we did just a while ago, we need to expand this as the integral of 1 minus 2u squared plus u to the 4th du, which expands further to the integral of du minus 2 the integral of u squared du plus the integral of u to the 4th du. So hence, I'm going to have u minus, this is 2 times u cubed over 3 plus u to the 5th over 5 plus c. Hence, let's rewrite it here. Integral of cosine to the 5th x dx is equal to sine x minus 2/3 sine cube x plus 1/5. Just bringing out the constants, 1/5 sine to the 5th x plus c. There you go. Now let's take a look at this example. Both at this time now they're a product of powers. In this specific case, you have both odd powers for sine and cosine. Technically, each would work whichever you would like to do, whether you would like to work with sine or whether you would like to with cosine. More or less, you need to do more or less it will be the same. However, it is usually recommended that we work with the smaller exponent. The smaller exponent will make the computation easier. So let's do that. Hence, the integral of sine to the 7th, let's rewrite the symbol now. Integral of sine to the 7th x cosine to the 5th x dx. So this is what we are going to work with. Therefore, I'm going to have the integral of sine to the 7th x cosine to the 4th x, then cosine x dx. So this is what we will need sine with. Hence, I'm going to have the integral of sine to the 7th x, then this becomes cosine squared x squared cosine x dx. If you already know how to turn this, then you can immediately go to the integral of sine to the 7th x times 1 minus sine squared x squared cosine x dx. So now from here, we can now do our substitution. So since anyway we need the sine, so if we get u is equal to sine x, du will be equal to cosine x dx. So from here, we can have then u raised to 7 times 1 minus u squared du. So at this point, it's better if we could expand this first. So this becomes the integral of u raised to 7. U raised to 7 times 1 minus 2 u squared plus u to the 4th du. Then again, distributing this, so this becomes the integral of u raised to 7 minus 2u raised to 9 plus u raised to 11 du. Alright, so from here, now we can separate this as the integral of u raised to 7 du minus 2 the integral of u raised to 9 du plus the integral of u raised to 11 du. So therefore, we are going to have u raised to 8 over 8 minus 2 u raised to 9 over 9 plus u raised to 12 over 12 plus c. Hence, the integral of sine raised to 7x cosine raised to 5x dx is equal to, it's 1 over 8 sine to the 8x minus 2 over 9 sine to the 9x plus 1 over 12 sine to the 12x plus c. So for odd powers, more or less what we need to do is to make sure that we just get just one from one odd power, just get one of that specific function, then convert the rest to its derivative. What if now we have an even power? So if we're going to go back for an even power here, we are told that we use power reducing identities. This one here. So for sine squared, we have 1 minus cosine 2x over 2. So let's bring that to that slide. again. So we know that, oops, sine squared x, according to our power reducing identity, is 1 minus cosine 2x over 2, which can also be written as 1/2 minus 1/2 cosine 2x. So with this in mind, we can now use this to replace the sine squared applied identity and then work from there with our integration. So following this one here, or we can also, I'll work with the second one instead. So since it's the integral of sine squared 3x dx, can take this form, and we let x, quote unquote, this to become 3x. So therefore, this becomes the integral of 1/2 minus 1/2 the cosine of 2 times 3x dx. So there. So I'm going to have the integral of 1/2 minus 1/2 the cosine of 6x dx. So again, if we have an even power, what we're doing is we're applying the power reducing identity. So from here, we can easily now have this as, oops, this becomes now 1/2 integral of dx minus 1/2 integral of cosine 6x dx. This one we can easily work with these integrals. I'm going to have 1/2 x minus 1/2 here. If we're going to let u be equal to 6x, du will be equal to 6 dx. Hence, 1 over 6 du is equal to dx. So I'm going to have 1/2 times 1 over 6 integral of cosine u du. Now, we're going to have 1/2 x minus 1/12 multiplying that sine u plus c. Hence, u is equal to 6x. Therefore, the integral of sine squared 3x will be equal to 1/2 x minus 1 over 12 sine 6x plus c. There you go. So, the same goes if we have products of these powers. So, here, we have to change the powers, the even powers, into these power reducing formulas. So, even though if the power will be a bit higher, for example, it's sine to the fourth, let's go back here. For example, only you have a cosine to the fourth x, then it becomes, since cosine squared x is equal to 1 plus cosine 2x over 2, then cosine to the fourth x will become equal to 1 plus cosine 2x over 2 squared. So take note of that if you deal with higher even powers for sine or cosine. Now going back here, we're just with the power of 2, but it's both on sine and cosine. So we will need to use the power reducing formulas for both. If you recall, sine squared x is equal to 1, that's 1/2 minus 1/2 cosine 2x. Cosine squared x is 1/2 plus 1/2 cosine 2x. In this case, I'm going to combine them together. That's 1 minus cosine 2x over 2, 1 plus cosine 2x over 2, and we'll see later why. Sorry for the ugly handwriting. So, the integral of sine squared x cosine squared x dx is equal to, following our power reducing formulas, it becomes 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2 dx. Now, as you can see, I have this. And with our knowledge of special products, it would be easier if we're going to multiply them as such. Hence, I'm going to now have integral of, that's 1 minus cosine squared 2x over 4 dx. Hence, I'm going to have the 1/4 integral of 1 minus cosine squared 2x dx, which is something now that we can easily work with. We can have 1/4 the integral of dx minus 1/4 the integral of cosine squared 2x. So we can easily work with the integral of dx, but here we're going to work with, again, even power. So like what I mentioned a while ago, if we're going to work with this, we're going to use this one. Since I began working with the condensed form, let's work with the condensed form. Since I'm not going to multiply, it might as well work with this instead. So I'm going to now have, that's 2x, so this becomes now 1/2 plus 1/2 cosine of 2 times 2x. Hence, I'm going to have 1/4 integral of dx minus 1/4 integral of 1/2 plus 1/2 cosine 4x dx. So therefore, I'm going to still have 1/4 integral of dx here, minus this time I'm going to have 1/8, that's 1/4 times 1/2 integral of dx, plus, that becomes minus because this is negative 1/4 minus 1/8, negative 1/8 plus 1/2 the integral of cosine 4x dx. And we know here that we can just let u be equal to 4x, du would be equal to 4 dx, hence 1/4 du would be equal to dx. Let's break that down. So now, performing the integrations, I'm going to have 1/4 x minus 1/8 x. In this case, I'm going to have 1/8 times 1/4. The integral of cosine is simply positive sine 4x plus c. So there. So I'm going to combine these two here. So this becomes negative 1/8x minus 1 over 32 sine 4x plus c. Therefore, integral of sine squared x cosine squared x dx is equal to negative 1/8x minus 1 over 32 sine 4x plus c. And those are the techniques in integrating functions involving powers of sine and cosine.